Hello and welcome. Let us read the problem. A stone is thrown from the roof of a 12-meter tall building A, the building is A, with a velocity of 2i cap plus 8j cap meters per second. After 1.2 seconds, it strikes the roof of a building B. Find the height of the building B, right? And you are supposed to take G as 10 meters per second square. So let's draw this building A, and let's say this is the ground level, and this is building A, and which is 12 meters high. And a stone is thrown from the building, and it is thrown at this velocity. Its horizontal component of that velocity is 2 meters per second. Its vertical component of the velocity with which it is thrown is 8 meters plus 8 meters per second, right? And this stone, let's say it's thrown like this, and it will come down. Now we don't know, this stone is going to land, it's going to strike the roof of the second building, right? So it's going to fall on the top of the second building. Now we don't know whether the second building has height less than 12, right? Or it could be more than 12 meters. We don't know that. So how would you draw this figure? Now one way to do this is assume that, let's assume that this stone is going to, the second building is also of the same height as of the first building. It's just an assumption. It may not be true, right? That means we'll be drawing, the building will come somewhere, so the stone is going to fall like this somewhere, okay? Suppose the stone falls here at the same level. That means the stone is starting from certain level and it is reaching the same level, because we are assuming the building to be having 12 meters of height. In that case, what will be the vertical velocity of this stone which is landing on the building of the same height? It's going to be -8, right? Because see, the stone is thrown here in this fashion, and its initial vertical velocity is +8. If it is going to land at the same level, the velocity at this point is going to be -8. Ground to ground projectile. You can see my earlier videos. So if the projectile is starting from a certain height and is reaching at the same height, then the vertical velocity with which it reaches the ground, right, is going to be same as the initial vertical velocity of this, with different sign because it is turning its direction, right? If this is positive, upward positive we consider, so this is going to vertically downward velocity will be negative. So here the vertical velocity here at this point will be -8, okay? So what will be the time required? So one can say that it's like this: you throw a stone up with the we are saying that it's going up and coming down at the same level, and we are saying that we want to find out, let's find out the time it would require to reach this level. So how will you find out the time? We would say that we can use the equation v is equal to u plus at, right, and find the time. Final velocity here would be -8, right? So basically we are saying that t is equal to v minus u by a. Final velocity, if it is reaching the same level, is going to be -8 minus initial velocity, vertical velocity is 8 plus 8. So it is 8 minus 8 upon acceleration downward, it is going to accelerate downward, so it is -10, right? So this time is going to be 1.6 seconds. 1.6 seconds. If the stone were coming at this level, the time it would have taken is 1.6 seconds. But the time the stone has taken to reach the roof of the second building is 1.2 seconds. That means the stone has not come up to this point, it has been intercepted somewhere here, right? That means the second building must be taller than the first building, because the time required to land on the roof of the second building is less than 1.6, okay? So we can draw the second building now more correctly, saying that let's say the second building is, say, this is second building, and we want to find the height of this second building, right? So the stone is landing here. That means we can say that the stone has this, let's say this distance is h. This is the difference in height between this building and this building. So this is the net, this is the vertical displacement of the stone. Vertical displacement of the stone is h. So you know that the problems on projectile can be solved by isolating the vertical and horizontal motion, right? So it is exactly, suppose you from this building you throw a stone vertically upwards with the same initial vertical velocity of 8 meters per second. This stone, which is thrown exactly like this but with the same vertical velocity, will reach the same height, right? Same height, and it will come down. It will come down along the same line, and after 1.2 seconds it will be somewhere here. So it's coming down. I'm showing some distance, but it's along the same height. So it's going to reach here, right? So this will be after 1.2 seconds. So you can now consider this as a rectilinear motion. So this is the displacement upward, because the stone is thrown up and it is reaching here. That means it has moved up by this much height, h. This is your vertical displacement, right? It's positive vertical displacement. Time required, as we have said, is given 1.2 seconds. 1.2 seconds. So we can write the equation S is equal to ut plus half at square, right? S is our h, this h, right? Initial vertical velocity is 8 into 1.2, because time required is 1.2, plus half. Acceleration is downward, so it is minus 10 into, we can say t is 1.2, so it is 1.2 square. So we can solve this. This will be 12 into 8, 96, so it is 9.6. This can be written as, so this is a minus sign taken out, half into, I'll say 10 into 1.2 into 1.2, right? Just simplifying this. So it is 9.6 minus 10 into 1.2 is 12. 12 by 2 is 6, right? So 6 into 1.2. So you will get 9.6 minus 7.2. 9.6 minus 7.2 is 2.4 meters. So you will get h as 2.4 meter. That means this total height is 12 plus h, right? So total height will be 12 plus 2.4, that is 14.4 meters. Thank you.